and welcome to the Latino STEM Alliance and Boston Public Schools OIIT webinar series. Step-by-step programming with your EV3 robot. This is the third of a series of 5 webinar tutorials for sensor use and programming basics to prepare you for our game challenge and competition at the end of the school year. Our live webinars take place every other Wednesday from 3 to 4 p.m. The next series will be held on Wednesday, January 20th. Today's webinar will focus on the switch program command, the if-then, and nested switches. We will use the touch sensors along with the ultrasonic and light sensor attached to your robot. As before, you will need your built robot and EV3 software application open to actively participate with the live webinar, as well as signing on to the back channel to post questions.
We'll get started by introducing a useful tool in programming, one of the flow control programming blocks called switch. And the switch block can be treated as a sort of if and then statement. So if you see the image here sort of explains the logic of it, where you find a condition that you want to focus on, and then you have 2 separate actions, action A and action B. And if the condition ends up being true, you take action A, and if the condition is false, you take action B. So one real-world example of that would be if it's raining. So the condition is it raining? If the condition is true, you wear rain boots. And if the condition is false, you wear sneakers. So this type of logic can also be used when programming your robot with the switch command. So one example we can see here, same layout, just with more robot-related conditions, is with the touch sensor. And the condition is that sensor actually pressed. If the condition is true, the robot will drive forward. And if the condition is false, the robot will stop. So we're going to show you how to actually program this condition using the switch command in the EV3 software. Great, so we'll start by showing you where the switch command is in the orange tab. It's the flow control. You'll see the switch block right here, and we can drag and drop it down. Let's get that on the screen. So here, one of the first things you notice about the switch is there's actually 2 paths. And that's sort of different from any of the other sensor blocks we've seen before, but it matches what we showed you before with the two conditions. You got a check mark up here for true and an X here for false. So that's our true path and our false path. Now, just like the other command we used before, wait, this switch command can be used with any of the sensors. And we said our first condition was going to be using the touch sensor to see when it is pressed or not. So we're going to go to touch sensor and compare state. So now that we have this set for the touch sensor, that means that the true condition is going to be when the button is pressed, and the false condition is when it's not pressed. So we mentioned that when the condition is true, we want that robot to drive forward. So in order to do that, take a move tank block and put it inside of the true statement, or the true path. So 2 powers of 75 will have that move forward. And then we'll take another move tank command, put it in the false statement, and set that to off, so that our robot is off. So now this almost looks like it's complete. But there's one major thing that we need to take care of first. You know that the robot reads this program from left to right, which means it's going to check this statement once, and then after it checks it once, it's going to execute that command and be done. But we don't want it to do that. We want it to be continuously checking this condition, which means that we actually want to put this switch inside of a loop. And this is almost always true for any time you use a switch command, is that you want it to be sitting in a loop. That way it's constantly checking. And one other thing is that we need to change the duration of this move. So if we had the move set to 1 rotation, like it is now, that means that if it checks and the button is pressed, it would drive forward for 1 rotation. During that 1 rotation, it would not be checking for the bumper, it would just drive. But we really want this to be constantly checking while it's driving. So we set it, instead of for a condition, just to on, which means when the button is pressed, that's the power the motors will have. But it's not waiting, it's just constantly checking to see when it's released again. So now that we have this inside a loop, we see that the sensor should be constantly checking to see if it is pressed or not. And when it is pressed, the motor should be driving with straightforward, both powers at 75. And when it's not pressed, the motor should turn off. So we'll download this to our robot and give it a try.
We need to add the touch sensor to this.
Oh yeah.
So that's going into port 1.
Yep, it's set to port 1 right now.
There's our robot.
Great. So we've got the touch sensor just sort of hanging off the robot right now, so I'm going to hold on to it. And I'm going to run the switch touch program. Okay, so it's running, and like we said, when the condition of the button not being pressed is met, the false condition, it's not going to drive forward. So as soon as I push this button, the motors will spin. But while it's spinning, it's still constantly checking that sensor for the state. So as soon as I release this, the motors stop again. So there is a basic example of how to use the switch command to check the condition of a sensor and have that actively change the state of your robot. So that is one program that uses one simple switch command. Now what we're going to show you are nested switches, which are ways of checking for multiple conditions. So this really had one condition, that one sensor being pressed. And if you start nesting switches, you can start achieving more complex scenarios that look at different types of conditions. Here is a nested switch. If you look at it, there's multiple conditions. It looks like a lot, but it's really just two. So now what we're going to do is try to use two different touch sensors plugged into the robot at once. So what it'll do is check condition one, is that first sensor pressed, yes or no? And regardless of whether it is or not pressed, it's going to check for the second sensor and then see if that is pressed or not. And after we do that, that gives us four complete conditions, four separate conditions. One where they're both true, one where sensor one is true, but sensor two is false, one where sensor one is false, but sensor two is true, and one where they're both false. And we're going to tie that into motor control. So if both sensors are pressed down, then both motors will turn on. If both sensors are false or neither are pressed down, then both motors won't run. And then if just sensor one is pressed, but sensor two isn't, then motor B will run and C won't. And if sensor one is not pressed and sensor two is, then motor B will not run and C will run. So we'll be able to get our robot to drive forwards, turn left or right, or not drive at all, using nested conditions looking at two separate touch sensors. Okay, so instead of starting from scratch, I'm just going to erase what we had first. So now we have what that first condition was of checking for the first sensor, our first bump sensor in port one. But now what we want to do is after that condition is met, whether it be true or false, we want to look for the second sensor and look for that condition. So I'm going to drop more switches. This is bigger than the screen fits. More switches. Oh, right here. It's going to get a little small. So here's the full thing, and I think I'll zoom into each one of them as we do them. But here's the first switch, and then we're going to change each of these to look for, a sensor in port 2. It's not being used, right? 1, port 2. So now this first switch is going to look for a bump sensor in port 1, and the second ones will look for a bump sensor in port 2. That way they're looking at two separate sensors. So here's the four conditions we talked about. One where they're both true at the very top, true, true. One where they're both false at the very bottom. And then the two middle ones are where one is true and two is false, or where one is false and two is true. So now we need to enter in the motions that we wanted for those individual conditions. And we'll start at the top. So when both conditions were true, we wanted both motors to turn on. So I'll drop a drive tank down and have that set to both motors going at a power of 75. And again, this is inside a loop, so we want no duration, just for on. And then when sensor 1 is pressed, but sensor 2 is not, we want motor B on, but motor C off. So on, and then we're going to give motor C a power of 0. So now motor B will run at a power of 75, and motor C will not. And for our third condition, when sensor 1 is not pressed, but sensor 2 is, we want motor B to be at a power of 0, and motor C to be on at a power of 75. And then when neither are pressed, we just want both to be off. Okay, so let's zoom out. There's a lot more vertical programming than we've done so far, but you can see how we're checking for two conditions. There's sensor 1 here, and then sensor 2 at the top and bottom. and then our 4 conditions and 4 actions we want to take based on those conditions. So I'm going to run the program switch nest, and because neither button is being pressed, we've got sensor 1 and sensor 2 here. Should I go further away? So now that we've got both sensors here, neither motor is running because neither sensor is being pressed. If just sensor 1 runs, motor B runs, but motor C does not. And then if only sensor 2 is pressed, motor C will run, motor B will not. And then if both are pressed, both of them run so that it drives forward. So this is an example of using the different switches almost like remotes to drive and steer your robot. So that's how you can use nested switching to take into account multiple sensors at once. Next, we'll show one more example of nested switching using a different type of sensor, specifically the ultrasonic sensor, to look at conditions for multiple types of distances.
So that's this one right there.
So we're going to use the ultrasonic sensor.
I'm going to put it to the front of the car facing forward.
And ultrasonic wants port 4. We can program it.
Yeah.
So I'm going to start by clearing almost everything. Should we show
slide
the conditions
first?
on the
Let's
slides?
show, yeah, let's show the slide first.
So here's what we're going to try to program. So you have 2 conditions here. One condition is the distance measured greater than 12 inches? If that's true, then we're done, and the robot drives forward. If that's not true, then we check another condition, and that's is the distance greater than 8 inches? If that is true, the robot will just stop. And if it's not true, then the robot drives backwards. So basically, if it sees something greater than 12 inches away, it'll continue to drive forwards. If it sees something between 12 and 8 inches away, the robot will stay still. And then if it sees something closer than 8 inches, it'll actually back up until it's at least 8 inches away. So we'll see if we can program that now. So now we've got just a single switch command inside of a loop. It's still stretched out. Let me start fresh so that these are normal sized to start with. So start by placing a loop down and a single switch. Great. And now this switch command, instead of the touch sensor, we want to look at the ultrasonic sensor and compare distance in inches. And good, that's in port 4. So we said our first condition, we wanted to see if something is greater than 12 inches away. So we're going to change this operator here to greater than, which is operation 2, and then 12 inches. And if that condition is true, which is the top slot, top path, we want our robot to drive forward. So if the sensor sees any distance greater than 12, our robot will drive forward. And if it sees a distance less than 12, we wanted to check for its second condition. In that condition, again, we have to set the sensor. It's for the ultrasonic sensor to look at distance in inches and see if anything is greater than 8 inches away. And we said if it is greater than 8 inches away, that means it sees something between 8 and 12 inches. So we want our robot to stop. And if that condition is false, that means it sees something less than 8 inches away, in which case we want our robot to actually back up. So on for negative 50 for each. Now if it sees something greater than 12 inches away, it'll drive forwards. If it sees something less than 12 inches, it'll check to see if it's greater than 8. If it is, it'll stop. If it's less, it'll drive backwards. Great. Okay, so this will be our wall. Get this to run, and it should drive forward until it gets to about 12. And then it stops right there, which means that this is at about 12 inches. So if I back it away, it'll keep driving forward until it gets back to it. And again, the second condition is that if it's less than 8 inches away, it'll back up. So if I start moving it forward, it'll back up to keep that 8 inches. So this is an example of looking at 2 different distance conditions and having 3 robot actions of drive forward, stop, or back up to maintain a specific distance. So those are all some pretty interesting examples of what you can do with Switch, especially when you start nesting multiple switches together.
So for this week's homework, we're going to have you try doing the 2-button remote controller, which is one of the examples that we just did a few minutes ago. So using 2 touch sensors to control the 2 motors. And you could set up an obstacle course in your room and try to navigate through that course. And you could even have little competitions within your class if you have multiple robots doing that. The second assignment we want you to try is the line follower, which if you recall from last time, maybe I should demonstrate that.
Oh yeah.
But the line follower is when you follow an edge of a line by turning one way if it's off the line and turning the other way if it's on the line. Last time we did that with the wait commands. This week we want you to try doing the same program but using switches. And so we have the program programmed on this robot. So let me just show you what we mean. So the line is there. So now it's turning right when it's on the table and turning left when it's on the line and going back and forth. So the robot will behave pretty much the same way as it did last time with the wait commands. It's just a different way of programming the same outcome. And just showing it to you in a diagram form, this is basically what the program will be doing. So the condition will be light sensor value greater than 40, or depending on the surface you have, that might be a different number. And then if it's true, you turn one way. If it's false, you turn the other way. The right and the left and the light sensor value might change depending on what kind of surface and what kind of tape you have. And then the third assignment, if you get done with those two, is to make a multi-sensor table bot. And that's what we mean by that is to use a light sensor or some other sensor to keep a robot on the table, same as last time, but add more sensors so that it can avoid obstacles such as walls or objects placed on the table. So you could have a light sensor looking down to detect the edge of the table and an ultrasonic sensor pointing forward that can avoid an obstacle. And you'll, again, be doing that using switches rather than weights. The reason why we want to do the switches rather than weights, although they seem to accomplish the same thing, is that the weights are expecting certain things to happen in order. So like on a line follower, if you program it using weights, you always need to either start it on the table or on the tape, depending on which way you programmed it. But if you have the switch, you can start it anywhere you want, and the robot will figure out where it is. So using the switches will give you a little bit more flexible way of programming. Same thing with the multi-sensor table bot. If you just use the switches and you say, wait till you get to the edge of the table, then back up and wait till you see another obstacle, then those things need to happen in the same order each time. But if you use switches, regardless of when the robot encounters the edge or obstacle, it'll be able to react to that. One major suggestion is to make sure you have the loops around the switches. That's one of the main problems that we see people having when they first use switches, is to forget the loop. And the program will just run once, you'll check the condition once and end. So you'll see the robot twitch a little bit and then stop. So if you see that happening, you'll know that that's because you forgot to put the loop in there. Anything else I missed?
Troubleshooting wise, make sure same as loop, make sure that I mentioned this before, make sure the duration of your move commands is off, so that it's just set to on, not for duration. Because if you have a duration in there, it's not going to be checking for conditions while it's running.
We thank you for tuning in to today's webinar. And again, we encourage the students to try the homework challenges. And if you do happen to try and video your work, please submit it to the Google Classroom site by a link, and that will count towards your first presentation and consideration for a pizza party in January. The video files can be submitted from a Google app on your phone as well. And see the Google Classroom site for reference on instructions how to download that app on your phone if you wish to do that. We look forward to seeing you at our next webinar, airing live on Wednesday, January 20th from 3 to 4 p.m., covering more sensor use, programming, and the game reveal. So again, we thank you for tuning in, and we'll see you next time.
Thank you. Bye-bye.